So now we're dealing with reactions. Draw and name the major product. If more than one of these contains a chiral stereogenic carbon, assign whether it's S or R. So starting off with propene. Well, there's propene. You've got carbon 1, carbon 2, carbon 3, double bond. We're reacting it with HBr. Now, we're not doing it in any funky way. So that means that the Br goes on to the more substituted carbon, which will be that one, and the H goes on to the less substituted carbon. So we're just going to draw bromine on the middle one, H on the end one, just like that. Okay, now, is there a chiral carbon here? And the answer is no. And it's sort of, this is where the way we're drawing things can confuse things. This carbon here is a CH3. This carbon here is a CH3. So this carbon, the 2 carbon has a hydrogen, a bromine, and then 2 CH3s. So we don't worry about it being chiral. Bromine plus Br2. Well, of course, what we're doing here is we're just going to add 2 bromines over the double bond. So bromine there, as you see, 1,2 dibromopropane. But if we look at this carbon here, right, carbon 2 has got a bromine, it's got a hydrogen that's not drawn, it's got a CH3, and it has a CH2Br. So 4 different things on carbon 2. It's a chiral carbon, a stereogenic carbon. So let's worry about what's made. Well, if we think back to the mechanism of this reaction, it goes through this beautiful bromonium ion. Okay, so bromine pops on to the double bond and ends up with that little triangle. Now at this point, the other bromine can come in and attack from the bottom, and it can attack from the bottom on this carbon or this carbon. So there it is attacking from the bottom on this carbon here, which is carbon 2. And there it is attacking from the bottom on this carbon, which is carbon 1. Okay, and so you can see that there is a very distinct difference between these 2 structures. Now let's look at this carbon 2 and think about assigning priorities. Obviously, bromine is the best. CH2Br is the next best. CH3 is the number 3. So we're going 1, 2, 3. So that's going, of course, anti-clockwise. But the trouble is we've drawn this with the hydrogen coming out at us. So hydrogen going away from us, anti-clockwise is S. Hydrogen coming out at us, anti-clockwise is R. So this is the R12 dibromopropane. So you better hope this one is the S. Let's make sure. So bromine number 1 priority, CH2Br number 2 priority, CH3 number 3 priority. So here we're going clockwise. Clockwise with hydrogen going away from you is R. So clockwise with the hydrogen coming out at you is S. Now, we're told which is the major product. Well, in this case, it's a 50-50 shot, really, isn't it? We've got this bromonium ion. The bromine can come in here or it can come in there. So I'm going to say both of those are the major products. Should point out, by the way, that A-level are not going to ask you to do R or S. Propene plus H2, well, that's easy. We just take our propene and stick a hydrogen on each of the carbons. So there we are to make propane. One of those nice easy ones. Just change that third to the end letter from E to A, and you got the question right. So now we're changing to 2-methylpropene. There is 2-methylpropene, 1, 2, 3, with the 2-methyl off there. And I'm going to react it with the same thing. So HBr, the Br very definitely going to go on the more substituted carbon, that one, the hydrogen on the less substituted. So you get this product here. 2-bromo, 2-methylpropane. Now the question is, do we have any chiral stereogenic carbons? This carbon is a methyl group. And this carbon with the bromine has got 1, 2, 3 methyl groups on it. So definitely not a chiral issue. Add in Br2 here. So Br2 goes on, we saw before, bromine on each of the carbons. Do we have to worry about chirality, stereogenic carbons? And the answer is no. This carbon has got 2 hydrogens. This carbon has 2 methyl groups. And then, of course, react it up with hydrogen. All you do is you slap a hydrogen on each of those and you go from 2-methylpropene to 2-methylpropane.